So today we will start digital electronics. So far, whatever circuits we have learned were dealing with analog signals. Now today we will go to digital electronics where digital signals are used. Do you know the difference between analog and digital? What is the difference between analog and digital? Analog means continuously varying. Digital means it has only certain discrete values. So let us see in analog signal, it is continuously varying. For example, if I draw a graph between time and voltage, suppose the peak voltage is 5 volts, 5 volt, then the signal will vary continuously like a sine wave. So this is an example for analog signal, continuously varying signal. With time, see it becomes 0 and goes gradually from 0 to maximum, becomes 0 again, goes in the other direction. So this is continuous variation like a sine wave. But a digital signal looks like this. For a digital signal, if we have a digital signal with maximum voltage 5 volt itself, voltage is taken along the y-axis, time is taken along the x-axis, then the signal will look like, if it is 0, okay, then it will come to a maximum, then it becomes 0, then it comes to a maximum, then it becomes 0. So see, it's not continuously varying. It has either 0 value or the maximum value. Now the 0 value, we call it as 0. Okay. And the maximum value, whatever constant voltage it is, we call it 1. So 1 doesn't mean that it is 1 volt. It can be any constant voltage like 5 volts, 6 volt, 3 volt. So whatever be the highest voltage. So in a digital signal, it will just vary between the 0 value and the highest voltage value. So the digital signal will look like this, while analog signal means it is continuously varying. Is this clear to you?
Yes, teacher.
For digital electronics, we deal with digital signal, which means it's a stage where the voltage is off, that is 0, or the voltage is a constant value on. So you can say that this is also a off-on stage. So it just switched between off-on stage. And in whole of the digital electronics, when we are dealing with the basics, there are 2 areas that comes when we come to the basics of digital electronics. One is the number system. And then comes the logic gates. So number system and logic gates. Today we will deal with number system. We will be discussing 4 number systems. So let us see what are those 4 number systems. Maybe you have some idea about the 4 number systems. What are the different number systems you have learned?
Binary.
Binary.
Hexadecimal.
Which is the number system we commonly use? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Decimal.
It's the decimal number system. So let us see what are the 4 number systems which we will be studying. Number systems. 1 is the decimal number system, the one which we usually use. Then the binary, as you told. Then we have the octal number system, and then we will be dealing with hexadecimal number system. And each of these number system has a base. What is meant by the base? Base means the number of digits or number of symbols used in that particular number system. So the base, what is the base for decimal number system? The usual numbers which we use. Its base is 10. And what is because what its base is 10. So let me tell what are the digits also. So digits in the decimal number system having base 10, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. See how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 digits are used in this decimal number system. So we call it number system to the base 10. So in binary, what is the base?
2.
2. And what are the two digits used in binary number system?
0 and 1.
0, 1.
0 and 1. Okay. 0 and 1. Now, what is the base for octal system?
8.
8.
8. And what are the digits used?
0 to 7.
Yeah, 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. So these are the digits used. And hexadecimal, how many are there? What is the
60.
base? Yes, 60. And what are the digits? So it goes from 0 to 9, which are these. So that forms 10. And the remaining are alphabets starting from A. So A, B, C, D, E, and F. So these are the digits 0 to 9. Then the alphabets A, B, C, D, E, F. So A stands for 11, B stands for, sorry, A stands for 10, B stands for 11, C stands for 12, D stands for 13, E stands for 14, F stands for 50. So these are not used, instead the letters are used. So is that clear to you? These are the whole number system and these are their bases and these are the digits used. Now let us see how we can express the decimal and binary numbers. And also each one of them, how we can express, and then we will see how we can convert one to another. Then we will see how we can add, subtract, multiply, and divide the binary numbers. So we will focus on binary numbers because in digital electronics, we usually use the binary number system. So we will be focusing on binary number system. And we will also discuss addition, subtraction, multiplication, and division of binary number system. So let us see how in each of the number systems a number is represented. Okay, let me take in decimal system. In decimal system, okay? In decimal system, let me express a number 235. Okay, so when we express a number 235, this will seem very simple to you, very trivial to you, but when we follow the method, I want you to focus on the method because we will be expressing everything with the same method. So let me see, tell you how we will express this. We have to start from the unit place and go towards the higher places. So we will be going in this direction. So its base is 10, right? So we have to tell for decimal system, the base is 10. So we can express 5 into 10 raised to 0 plus 3 into 10 raised to 1 plus 2 into 10 raised to 2. We can express like that. I started from here and went in this direction. So what is this? Is equal to 5 times, what is 10 raised to 0?
0. Sorry, 1.
1. Any number raised to 0 is 1. So 10 raised to 0 is 1. So 5 times 1 plus 3 times 10 raised to 1 is 10. Plus 2 times 10 raised to 2 means 100. So this is equal to 5 plus 30 plus 200, which will give you 235. This is how we can express a number in decimal system without a decimal place. Now let us see how we express that when it comes to a decimal place. Let me express one number with only decimal places. 0.326. Okay. So when you are taking a decimal place, there is a decimal place here, you have to go in this direction. So without decimal, we went in this direction. So with decimal, we have to go in this direction. Okay. So I will start with 3. So 3 times 10 raised to, it's decimal, so minus 1. Plus 2 times 10 raised to, this is 2. So I took 2 times 10 raised to minus 2. Plus, next digit is 6. 6 times 10 raised to minus 3. And if there are more digits, it will go to 10 raised to minus 4, minus 5, minus 6, etc. So this is equal to 3 times 10 raised to minus 1. What is meant by 10 raised to minus 1? 1 by 10, right? So this is equal to 3 by 10 plus 2 divided by 10 raised to minus 2. So 1 by 100. 1 by 100 plus this is 6 divided by 10 raised to minus 3. So in the denominator, 1 followed by 3 zeros. So it will go like that. So this can be expressed as equal to 0.3 plus 0.02 plus 0.006. And you get it as 0.326 when you add. This is how we represent. So the next one, I'm going to write a number with both the decimal place and decimal place. You will tell me how I can express in this way. Okay. So let me take any number. For example, 75.32 equal to. So how I will represent the number just before the decimal? From where
5 into 10 raised to 0.
Yes, 5 into 10 raised to 0.
Plus 7 into 10 raised to 1.
Into 10 raised to 1. Plus.
Plus
3.
No.
Yes. 3.
Into 10 raised to minus 1.
Minus 1. Plus.
Plus 2 into 10 raised to minus 2.
2 into 10 raised to minus 2. Which is equal to 5 into 10 raised to 0 means 5 into 1, 5. Plus 7 into 10 means 70. Plus 3 into 10 raised to minus 1 means 3 by 10. Plus 2 by 3 into 10 raised to minus 2 means 100. So 5 plus 70, 75. Point. Because 3 by 10 is 0.3, 0.2. So you will get like this. So you know this way, right? So in the same way, if you represent in the same way, we can convert the binary. If you are representing a binary number, we can convert that into decimal number. Let us see how. So I will not tell you. I think you now know the procedure. So you have to tell me how to express the number. So let me start with binary numbers. So binary, we are converting to decimal. Binary to decimal. Okay, all of you listen. After this, I will give you some homework which you have to do. So binary to decimal. So first, let me take one number without any decimal places in a binary number. So it should contain only 0 and 1. So 1101. So this is to the base 2. So how can I express this? I will start from here and go in this direction. Okay, start from here and go in this direction. So I have 1 into 2 raised to, because for binary the base is 2. So 1 into 2 raised to 0. I have taken this one plus. Next is 0. So 0 into 2 raised to 1 plus. Next is 1. 1 into 2 raised to 2. Next is 1 plus 1 into 2 raised to 3. Okay. So this is equal to 2 raised to 0 is 2 raised to 0 is
1.
1.
1. So 1 times 1 plus this quantity will be 0. So 0 plus 1 times, what is 2 raised to 2? 2 square.
4.
4.
4 plus 1 times 2 cube.
8.
8. So you got this as equal to 1 plus 1 times 1, 1 plus this is 0. 4 plus 8. 1 plus 4 plus 8 is 1 plus 4, 5. 5 plus 8 is 13.
13.
So this is 13 to the base 10. So we have converted a binary number to a decimal number. Is that clear how to convert the binary to decimal?
Yes.
If there were no decimal places. Okay. Now let me consider a binary number with decimal places only. So let me consider a number 0.011. So this is a binary number with a base 2 having decimal places only. So I'm not considering the 0 point. It's 0. So let me go in this direction. Okay. So I have to start with 0. So 0 times 2 raised to minus 1. I took this one. Next comes 1. So plus 1 times 2 raised to minus 2. Next is 1. So plus 1 times 2 raised to minus 3. So this is equal to, this is 0 times. So this can be avoided, 0 multiplied by. So this is 0 plus, what is 2 raised to minus 2?
1 by 4.
1 by 4. 2 raised to minus 2 means 1 by 2 raised to 2. 2 raised to 2 is 4. So I have to write it as 1 by 4 plus, what is 2 raised to minus 3?
1 by 8.
1 by 8. 1 by 8. So this is equal to 0 plus, what is 1 by 4 in the usual way?
0.25.
0.25 plus, what is 1 by 8?
0.128. 0.125, sorry.
0.125. Just
5.
remember at least till 1 by 8, okay? So you can convert 3 decimal places of binary easily. So just remember that 1 by 8 is 0.125. The other one, 1 by 2. What is 1 by 2? 0.5. 1 by 4 is 0.25. And 1 by 8 is 0.125. At least remember until that. So this is equal to, when you add this, you will get 0. So this is the highest one, 5. 2 plus 5 plus 2, 7, and 1 here. No, that's So let me add like 0.125 plus 0.25. So you get 573. Got it? So this is equal to 0.375 to the base 10. So you got how to convert the decimal part and the other part without decimal. So can I write a binary number with a decimal part and the other part? And will you tell me how to convert?
Yes. Yes, teacher.
Okay. So let me just, I think this you must have learned before. This is a quick revision of what you have learned in your computer period. So let me take any binary number. Let me take it as 1010.101. Okay. So this is to the base 2 and we want to convert it to decimal. So this is equal to, so first let me take this part. So how should I start? Tell me.
0 into 10 raised to 0
0 into 10 raised to 0 plus
plus 1 into 10 raised to 1
10 raised to 1.
plus 0
Is
into
it
10 raised to
correct?
2
The man, is this correct?
No, we
No.
start with 1.
plus, right?
What is the mistake, Hasina? Tell me.
When there is a binary, then
Oh, sorry, 2. Sorry.
It should
2
not be
raised to.
10. Okay?
Yeah, 2.
2. So this is a careless mistake. Usually we all do that. Don't worry. So should be in this direction. This should be. Okay, start Zaman. 0 times 10 raised, not 10. Again, I'm going to write that. 2 raised to. 2 raised to 0 plus. Next is 1. So 1 into, tell me. 2 raised to 1.
2 raised to 1 plus 0 into 2 raised to 2 plus 1 into 2 raised to 3
Finish.
plus, yeah,
Plus.
this is finished, plus 1 into 2 raised to minus 1
Yes.
plus 0 into 2 raised to minus 2
Plus.
plus 1 into 2 raised to minus 3.
Minus 3. So this is equal to 2 raised to 0 is 1. So
1.
1 into 0. So this need not be there. 0. Then 1 into 2 raised to 1. 2 raised to 1
2.
is 2. 2 into 1, 2.
2.
Plus, this is again
0.
This is
Plus 8.
2 raised to 3 is
8.
8. 8 into 1. So 8 plus, now this
Half.
half. 2 raised to minus 1 means 1 by 2 plus, this is
0.
0 plus
1 by 8.
1 by 8. So all of this is taken is equal to 0 plus 8 is 10.
2 plus 8.
2 plus 8 is
10.
10 plus 1 by 2 is 0.5 plus 1 by 8 is 0.125.
125.
So this is equal to 10 point. So
6 to 5.
6 to 5 to the base 10. So is this clear to you how to convert binary to decimal? Is this clear to you? I'll give you a homework.
Yes, teacher.
Okay. Now let us see how can we convert decimal to binary. So the reverse, how to convert decimal to binary. Now, suppose I have a decimal number that is 63 to the base 10. I want to convert it to binary. So how to do that? To do that, you have to divide with 2. So you have to successively divide with 2 and separate out the remainder. So let us do that. 63. So you have to divide it with 2. So 6 divided by 2, 3. 3 divided by 2, 1. And 31 and 1 remainder. So you have to write the remainder here. So the quotient is 31 and the remainder is 1. So again divide it with 2. So how much you will get?
15.
Yes, 16 and the remainder will be 1.
Teacher, 15.
No. What is 31 divided by 2?
15.
15. Yes, 15. Remainder 1. And again, you divide it with 2. What is the quotient? 7. Remainder 1. Again, divide with 2.
3.
3. Remainder 1. Again, divide with 2.
1.
1. Remainder 1. Again, divide with 2. What is the quotient?
0.
0. Remainder 1. And you have to write it from down to up. We will take another number because all of them are same. There is no 0 coming in between. Then we will know. But always you have to take from bottom to top, up. So this can be represented as 1, 1, 1, 1, 1, 1. So 1, 1, 1, 1, 1, 1. So to the base 2. So this is how we can convert a decimal number without decimal places to a binary. Okay. Now let us see what happens when there is a decimal place. So let me take another example which is only a decimal place. So the number is 0.64. Okay. 64. And it is to the base 10. So how will we convert? Now, to convert before the decimal point, we divided successively with 2. Here, you have to multiply with 2. Okay, you have to multiply with 2 and whatever comes before the decimal, only reserve that for the binary number. So let us see how it is done. So you have 0.64. So multiply that with 2. Okay. So 2 4s are 8. 2 6 are 12. So 2, 1 balance. So I am going to take out whatever that comes before the decimal place. So 1 comes out before the decimal place. Now again multiply this with 2. So 2 8s are 16. So 6, 1 balance, 2 2s are 4. So 4, 1 balance is there. So it will be 5 and nothing comes before. So 0. Again multiply it with 2. Okay. So 2 6 are 12. 1 balance, 2 5s are 10, 11. So 1 comes out. 1 comes out. So I have taken this out. Again multiply with 2. So you will get 2 2s are 4. And then 2 1s are 2. Nothing. So 0. Again multiply it with 2. So 2 4s are
8.
8. 2 2s are 4. Again nothing comes. And you can multiply with 2 and it goes on. So you,
How many times you have to multiply?
it doesn't matter. It goes on like that. But when we are expressing a number with a decimal place, we neglect the higher decimals, right? Once we get something in the calculator, it's 0.34562130, etc. It goes on. But we take few decimal places, right? So you can take few decimal places, maybe 3 or 4 you can take, or 4, 5 you can take. So the point is that here we came from down to up. Here you have to go in the reverse direction. So it doesn't matter. Once you get a 4 decimal place or a 5 decimal place, it is fine. It will go on increasing. For only few decimal places, it will stop in between. Next example, I will take 1 which will stop. Okay. So this one doesn't stop. It will go on. But doesn't matter. When we write always in the decimal place, 0 point. Now you have to go down, up to down. Here you came up. So this time you have to go down. So 1, 0, 1, 0, 0, it will go. But we are truncating it at this point. That's all. That's how decimal places will be many, right? Sometimes it goes on like that. So here, is this clear to you? How to convert the decimal part?
Yes.
Okay, now let us take one example with both this part and the other part, both the decimal part and before that. So it will be clear to you. So let me take another number. Okay, 72.75. This will start. Okay, 72.75. So here to the base 10, we are going to convert into binary. So here you have to take the part before decimal part and after decimal part separately. So let me take 72. So first 72, you have to divide it with 2. So how much will be 7 divided by 2? 3, 1 balance, 12 divided by 2, 6. So 36, remainder 0. Okay. And then again divide it with 2, 3, 1. So 18 and remainder 0. Again divide this with 2, 9, remainder 0. Again divide it with 2. So it will be 4 with a remainder 1. Again divide it with 2, 2 with remainder 0. Again divide it with 2, 1, remainder 0. Again divide it with 2, 0, remainder 1. And we have to go upwards. Okay, we will write here, go upwards. So it will be 1, 0, 0, 1, 0, 0, 0. Not finished because we have the decimal part. How to convert the decimal part? You have to multiply with 2 successfully, right? So I'm taking 0.75, okay, and multiply it with 2. So 2 times 5, 10, 0, 1 balance, 2 times 7, 14, so 15, so 5 I will write, and 1 comes out of the decimal. So again, multiply it with 2. 2, 0, 2 times 5, 10. So 1. Done. Finished, right? Here it is finished. Got it? So it will be done till this. So you have to go this, we went from down to up. Here we have to come from up to down. So here I will write point up to down. So 1, 1 to the base 2. Is this clear to you? How to convert a decimal number with both decimal part and the other part to a binary number. Is this clear? Say yes or no.
Yes.
Okay. Now I will give you homework, but before that we have one more period today. So after that I will give you homework.